OpenStax, College Physics, Chapter 4, problem number 40. So I drew a flea because we're starting off with a flea. And the problem says, let me just read the problem to you because I'm going to get it wrong. A flea jumps by exerting a force of 1.25 times 10 to the negative fifth newtons, a thrust, straight down on the ground. So the flea is pushing on the ground with that amount. A breeze blows and exerts a force parallel to the surface of 0.5 times 10 to the negative 6 newtons, and the direction of the find the direction of the acceleration if that's the mass. So let's start off with the free body diagram. Now they kind of tried to trick you here, right? They said, oh, the flea pushes on the ground, of 1.25 times 10 to the negative fifth down. But we're drawing the forces on the flea. We want to find the acceleration of the flea. We need to know the net force for the flea. So what's the force on the flea? Well, if the flea pushes on the ground with a force of 1.2 times 10 to the negative 5 down, the ground pushes on the flea up 1.2 times 10 to the negative 5 newtons. So let's put that right here. F ground on the flea. See, I switched those. Okay. We have an air resistance force of 0.5, and this is parallel to the ground. So I'm just going to put it this way. Fa. And finally, we have the gravitational force this way. Mg. And we want to find the acceleration. Now, I don't know the direction of the acceleration. So I can't, the next thing we need to do is to pick, we were trying to do this, right? F net equals ma. And I told you before that, is that off the screen? No, it's right at the top though. I told you there's two kind of problems, right? Either I know all the forces and I can find the acceleration, or I know the acceleration and I can find the force. So in this case, I know all the forces and I'm trying to find the acceleration. And the next thing that we would do would be to pick our x and y axis. The best thing is to pick the axis, either the y or the x, in the direction of the acceleration, but I don't know that. So let's just pick the x-axis. We can't always get what we want, but sometimes we get what we need, right? So I'm going to pick x that way and y that way. And I'm going to, again, break Newton's second law into an x equation and a y equation. So F net x is going to be equal to what forces are in the x direction? Well, there's just that one. And I didn't write it as a vector, but that's fine. It's just this value right there. So I'm going to put Fa, and that's going to be m times acceleration in the x direction. So I can find the acceleration in the x direction. Ax is going to be Fa over m, which is going to be equal to, I'm going to put in my values, 0.5 times 10 to the negative 6 over 6 times 10 to the negative 7. Okay, and I left off the units, so we'll calculate that in a second. Now let's do the y direction, F net y. It's going to be equal to the ground pushing on the flea, Fg flea, minus mg, right? Because that's in the negative y direction. And that will be equal to the mass times the y acceleration. Again, dividing by the mass, I can get the y acceleration. Ay is going to be Fgf minus mg over m. Now, you could factor this, and I think I will, because if I write this over that, and that's just going to be g. So this is going to be equal to Fgf, which is that 1.2 times 10 to the negative fifth, 1.2 times 10 to the negative fifth, divided by the mass, 6 times 10 to the negative seventh, minus 9.8, because I had mg over m. Okay, let's get ax and ay. Calculator time. I don't want to drop my very nice chalk. See? It's this stuff. Can't see it. Okay, you don't care. I care. It's fine. Okay, this one right here, 0.5, scientific notation, which you probably could get without using here. 10 to the negative 6th, 6 times 10 to the negative 7th divided by, and I get 0.833 meters per second squared. Over here, 1.2, oh, drop, sorry. 1.2 times 10 to the negative fifth, 6 times 10 to the negative seventh, and then subtract 9.8, and I get 10.2. Now, that's the answer, but let's get a better answer. So if we sketch this acceleration, I know I have some small x, well, it's not that big, ax and ay. I know the components, so I can find the magnitude of a, or I could even write it as a vector. I'm going to write it in every possible way. So first, let's do this. The vector a is going to be the x component, 0.833x hat plus 10.2 y hat. I don't want to run that into that. Meters per second squared. That's the way I like it, because this is the vector answer. Now, I could find the magnitude. The magnitude of this would be the square root of ax squared plus ay squared, right? Because it's a right triangle, the magnitude is the hypotenuse of the adjacent side squared plus the opposite side squared square rooted. So that's going to be equal to, let's just put that in my calculator, squared, swap. There it is. Squared plus square root. And I get 10.23. And you'll notice it's very close to the y acceleration because this is very small, that's very big, so it's going to be closer to that value. That's that. Now we can also find the angle of the acceleration if we want to, because I know ay is right there, ax is right there, so the tangent of theta is going to be ay over ax, so theta would be the inverse tangent of ay over ax. So if I put in my values there, I get 10.2, 0.833 divided by inverse tangent, arc tangent, 85.3. There you go.